Hi and welcome to part 2 on tan graphs. In this video I will be doing a couple of tan graphs just to kind of show you how I go about them. So I'll just get straight into it. I've got this first example, y equals tan of 3x between 0 and pi. The first thing I want to do is I want to have a look at the period. The period is remembering pi on b, and b is 3 in this case, so the period is going to be pi on 3. The other thing I want to look at is my asymptotes. Now I use my little formula that I had before where n equals 0, n equals 1, n equals 2, and also n equals -1 and -2 and all the rest of them. So I can actually substitute this in here and find out what each asymptote is. Now when n is 0 I get 1 pi times 2b, and b is 3, so I get pi over 6. I sub in all of the other values, or just these two values, because I'm just going between 0 and pi, and I get pi and 6, pi and 2, 5 pi and 6. So what I'm going to do is I'm going to sketch those parts first, those asymptotes, pi and 6, pi and 2, and 5 pi and 6. And then I know that the middle point of this tan graph, because it hasn't been moved up at all, the middle point of that tan graph is going to be in the middle of these two asymptotes and these two asymptotes here. Okay, so I know that in between pi and 6 and pi and 2 is going to be my middle point, which happens to be 2 pi and 3. So I put a dot, and the same between those two is 4 pi and 3. It hasn't been reflected in any way, so I know that then it must go from down here up to up there. And the only other thing I need to remember is to label my intercepts and also label my endpoints as well, so pi and 0. Now yesterday I told you that you should always label them like this. So that's what I'm going to do for you now. Okay, and that's how to draw that first tan graph. Let me show you another tan graph over here. This one's a little bit trickier because it's been translated. So again, I have a look at my period. I need to always draw it like this, so write it out like this, because otherwise I don't understand. And my period is just pi over b, and b the number in front of x. It's always a positive number, by the way, so it's just pi in this case. And again, I try and find my asymptotes. So I sub in n equals 0, n equals 1, n equals -1, whatever, until I get all of the ones that I like. So here's 0, -1, +1, and I think +2 as well. But some of them actually exist outside my domain. -3 pi and 2 actually is outside my domain, so that is not relevant. 3 pi and 2 is the same. Okay. So that's because it has been sort of translated as well. So I put in my asymptotes, and I need to label them as x equals -pi on 2 and x equals pi on 2. Okay, and then I know that in the middle of those two things it will be I guess where the graph sort of changes a little bit, a point of inflection. It's not a stationary point of inflection, but it is a point of inflection. There, and that's also where my endpoints are over here, -pi and pi, and I'll write them like this just because it's good to get in a habit of doing that. Okay, so I know that it goes actually through the origin of 0, 0, and I know it's also been reflected in the y-axis, so that means instead of going up like that, it actually comes down like this. So there's a couple of graphs for you. Hopefully that can help you with 3.4, and later on I'm going to make a video of 3.5, just looking at a couple of sine, cos and tan graphs that are a little bit trickier, just so you can see how I go about working out these questions. So thanks for watching.